Good afternoon, everybody. My name is Edgar de los Santos. If you can hear me, can you please press the button with the hand? Perfect. Thank you so much. Today we're gonna start a training series regarding bridge evaluation. We're gonna have an introduction to bridge load rating in today's session, and then in the next session we're gonna talk about bridge rehabilitation. In today's session, we're gonna talk about what is the bridge load rating, the purpose of the rating, also the difference between the bridge design and the bridge load rating, also application of the rating levels, the process in Midas Civil as well. So, for those of you who do not know Midas Civil is an all-in-one solution. In the program, you can perform any type of analysis for any type of bridges, whether it's a steel girder, which is one of the bridges that we're going to talk about, or precast as well. You can also perform analysis for cable state, suspension bridges, segmental bridges, as well as slab bridges, and you can perform any type of analysis such as response spectrum, push-over analysis, moving load, and so on. So you can perform any type of analysis in the program, and you can use it as you've seen in previous session, or you can use it for any type of bridges. Now, going into the topic that we're gonna go over today, what is the bridge load rating? The National Bridge Inspection Standards defines the load rating as the determination of the live load carrying capacity of a bridge using as-built bridge plans and supplemented by information gathered from the latest field inspection. Is basically the capacity of load carrying of a bridge. It is expressed as a rating factor, which is RF, or as a tonnage, which is the for legal vehicles only, legal and permit vehicles only. The bridge load rating provides a measure of the bridge ability to carry a given live load in terms of a simple factor, which is the rating factor that we just mentioned. They are used to help in the decision making about the needs for load posting, such as here you see we can specify the limits of the weight that can pass through the bridge, or for bridge strengthening, as well as for the overweight load allowance, or for bridge closures. These are some of the usage of the bridge load rating, and this is pretty much explains why it's so important. How much can the bridge take, how much load can it take, or whether it needs some type of strengthening, or if the bridge needs to be completely closed. Now, talking about the difference between the bridge design and load rating, they are similar, but they have different aspects. The philosophy of the bridge design is to basically adopt a conservative reliability index and impose checks to ensure the serviceability and durability without incurring into a major cost impact. But in the case of the bridge load rating, it generally requires the engineer to consider a wider range of variables than just the bridge design. In rating, the added cost of overly conservative evaluation standards can prohibit as load restriction, rehabilitation, and replacement becoming increasingly necessary. The rating procedures presented in the LRFR, which is the code that we're going to go over today, recognize a balance between the safety and economics. In most cases, a lower target reliability than design has been chosen for load rating. The strength limit state to rating is done, and then it is a more selective basis than the prescribed for the ASHTO RFD bridge design specifications. In the application, when designing new structures, it is required that the rating factor is higher than 1 for the HL93 vehicle at the inventory level for LRFR load rating. Therefore, a legal load rating will be required on a newly designed structure. We're gonna define what the legal load rating in the next slide. So it changes in the below category in the existing bridge: life load, dead load, physical conditions, specifications, and laws. Those are the cases for the load ratings, and we're gonna go over each one of them. Midas Civil supports the LRFR load rating using the Part 8 only. And this LRFR methodology consists of 3 distinctive levels of evaluation: the design load rating, the legal load rating, and the permit load rating. We're gonna see what each one is for. In this, the first one, or the first level, is the design load rating. It measures the performance of existing bridges and bridge plan data block. The second legal load rating is a single safe load capacity and is used to determine the bridge posting. And the third level is the permit load rating, and it is applied to bridges having sufficient capacity, and also it is used to determine the overweight permit. So here are the 3 levels, and we're gonna go and define each one of them. So for the design load rating is the first level assessment of bridges. It is the measure of the performance of the existing bridge to the current LRFD bridge design standards. Plain simple. The life load at the design level, the HL93 load, is used using dimensions and property of the bridge in its present and inspection condition. The limit states in this case, the bridge are screened for strength limit state as per LRFD. As you see, this one is very standardized as per the LRFD bridge design standards. The evaluation at a second level of reliability is also an option for this load rating first level, and the rating is also considered all applicable LRFD serviceability limit states. The purpose of this one can serve as a screening process to identify bridges that should be low rating for legal loads, that should be evaluated basically. In this case, the bridges that pass the design check, which is the design load check, which is the rating factor higher than 1. At the inventory level, we have a satisfactory load rating for all legal loads that fall within the LRFD exclusion limits. So it's basically applying the LRFD standards to the load rating using the HL93. The level of design load ratings, there are 2. There's the inventory rating level and the operation rating level. The inventory rating level generally corresponds to the rating at the design level of reliability for new bridges in the AASHTO LRFD, but it reflects existing bridge and material conditions with regard to deterioration and loss of sections. This is the most important part of the rating. It reflects the existing bridge and material conditions. This is why the inspection is so necessary to perform the bridge load rating. And then we have the operation rating level, in which the rating is based on the operation rating level, generally describe the maximum permissible life load to which the structure may be subjected. Generally correspond to the rating at the operation level, may shorten the life of a bridge. Then we have the legal load rating. This is the second level rating, provides a single safe load capacity for a given truck configuration applicable to AASHTO and the state legal loads. In this case, the life load is categorized into 2 types according to the AASHTO LRFR. One, AASHTO legal loads as specified in the Article 6A4421A, and the notional rating load as specified in the Article 6A4421B, or state legal loads. Then we have for the limit states, the strength is primarily limit state for the load rating, and the service limit states are relatively applied, selectively applied. The purpose of this second level rating is the bridges that do not have sufficient capacity under the design load rating shall be load rated for legal loads to establish the need for a load posting or strengthening. So the second level is used for load posting and strengthening. Then we have the permit load rating, and as you might guess, this one should be applied to bridges having sufficient capacity for legal loads. So basically, permit load rating should be used only for the bridges that have rating factor greater than 1 when evaluated for actual legal loads. The live load, as its name mentions, uh, is a permit load. The actual permit vehicle's gross weight and axle configuration will be the live load used in the permit load evaluation. The manual for bridge evaluation categorizes permit loads into two classes: the routine annual permits and the special permits. As you might know, certain states might give permissions for certain vehicles to pass a bridge. So in this case, a permit load rating is used to determine the capacity of a bridge for certain vehicles other than the one specified in the um, standards. Then we have the limit states. The permits are checked using the strength 2 limit state load combination with the service 2 limit state load combination optional for steel bridges to limit the potential permanent deformations. The purpose of this permit load rating, as its names mentioned, the permit load, it checks the safety and serviceability of bridges in the review of a permit application for the passage of vehicle above the legally established weight limitations. So basically to give the check or the yes for a specific vehicle permit load. Here's the process of the load rating. So as you can see in this flowchart, it starts with the design load as per HL93 inventory level reliability. If the rating factor is higher than 1, then it's all good. You don't need the posting. There is no, and it may be evaluated for permit vehicles perfectly. If it's less than 1, then we have to go over this flowchart. We have to check the operating level. If it's higher than 1, then perfect. If it's not, then we have to go to a legal load rating. If it goes okay with the legal load rating, then it's fine. If it does not, then we need a higher evaluation load rating. We might need the load testing, site-specific load factors, direct safety assessment, refined analysis, and there's where different types of programs come in, such as the Midas Civil and so on as well. You can also perform it for the design load check. It's the one that we're gonna see today. And then if it does not comply with the rating factor, then you need to start the load posting repairs, or no permit vehicles and so on. So let's go into the program. Midas Civil has different functions to perform the bridge load rating. We have applied the rating as per pre-stressed concrete bridges and as well as steel bridges. The most important thing in the rating is the rating factor, and the program is able to define or to obtain or provide you with that rating factor for any type of bridge, basically. In this case, we're gonna see different bridges and how the definition of each one of the parameters is done. In this case, we're gonna have a steel composite bridge, which is the one that we're gonna do the rating first. And before we go into the program, I want to define the different standards of or parameters that are in the program. First of all, we have the rating design code. In this case, let's just focus on the steel design rating, and we're gonna see how it is performed in the program. Uh, you have the option of defining the actuality rating design code in the program, and as you can see, the program performs the load rating based on the code that you select. After that, we have the design parameters for the steel composite. You have an option for defining something called the system factor, and it can be inputted according to the article 6A424 provided in the manual for bridge evaluation. And it basically, what it does is the system factor is multiplied to the flexural strength and the shear strength, and therefore is applied to all the elements. You can define the system factor here, the number that you desire, and then you have the different options that you can apply in the parameters, such as the strength resistance factor. You can define the resistance factors for yielding, fracture, axial compression, flexure, shear connectors, and bearings. You can define the fee for each one of them. You can either update it by the code, as you can see here in this option, or you can define the factor in each one of the dialog box. Then you have the girder type for box or top sections. In this case, we have an eye girder, but in the case that you want to use the box girder type or top, you have the option of defining if whether it's a single box section or a multiple box sections, and you can also consider this Venant torsion and distortion stresses if you want. So as you can see, the program really gives you different types of analysis options for in this case steel bridges, and it can consider all the parameters in the rating for this particular type of analysis. Then you have the options for strength limit state. You can apply the appendix A6 for negative flexure resistance in web compact or non-compact sections. You can also apply the positive flexure in compact sections, or the post buckling tension field action for shear resistance. These are for the strength limit states options that you have in the program that you can use to make a more complete or detailed load rating for your bridge. Then we have the service limit state. In this case, you can limit the stresses in the structural steel, or you can automatically, or you can manually input the design load and the legal load or permit load stresses, limit stresses, whether it's compressive stress or the tensile stress. Then you have the fatigue limit state application, where you can apply the diagnostic test result, whether it's the measure by strain or displacement. So these are the parameters for the steel bridge load rating, and then we have the definition of the brace length. The brace length for the steel composite sections can be entered to calculate the lateral torsional buckling resistance in compression flange of an eye girder or the top flange of a top girder. These are used in the program to analyze and also to obtain the rating factors for the steel composite. If the lateral brace length is not inputted, the program will use the span length, entering the span information. There is a span information that you can also apply in the program, and the program is going to use that as a reference for the brace length. If the span information was not defined, the lateral brace length is applied to the corresponding element length. Then, so depends on how much you divide that element in your bridge, then the program is gonna take that. so you might as well just define it here so you can use the correct value. Then we have the fatigue parameters. You can define in the fatigue parameters whether you want to assign the same type for the IN and JN. Those are the two ends of the element. And then you have the category. Uh, the category is defined by 75 years ADT TSL, equivalent to infinite life. Then you have the ADT TSL number, which is the number of trucks per day in a single lane average over the design life. You can manually calculate it as per, in the code there are certain standards. You have the N, which is the number of cycles per truck that passes through, and then you have the wrapping stress range, which is used for the verification of fatigue. Flexure stress is calculated as per the summation of longitudinal bending stress and longitudinal warping stress range. You can auto calculate that, or you can manually input for the top and bottom flange. It's up to you. So as you can see, the program gives you a lot of flexibility when defining the different parameters of the bridge load rating. Then you have an option for defining the curved bridge, as is in this case that we have a curved bridge. You can insert the radius. Once you have the radius, you can tell the program which type of curve you're using. So the radius is used to review the shear connection pitch at the and the moment of inertia of area for the longitudinal stiffener attached to the web. You can also define the stiffeners. We're gonna see that later. And then you have the curve type. You have convex or concave. Depending on which curve type, you can define it here. Then we have something called diagnostic test result. Adjustment factor resulting from the comparison of measured test behavior with the analytical model can be considered to calculate the load rating factor based on the test results. So you can tell the program here the diagnostic test results that you have measured, and the program is gonna take that into consideration for the load rating. We have something called the rating materials. Here is where you can modify the materials for the calculation of the structure capacity. The materials used for the composite sections are provided in this case in the SRC material properties, and the material should be defined as an SRC for the steel composite. Here you have the option of defining the steel girder section material. Here you can define it as per the code. We have the standards such as ASTM in the program, and you also have an option for defining the hybrid factor, which we're gonna see in the next slide. Then you have the concrete of the slab and also the steel rebar to consider for the reinforcement of the slab. These two, you can define them here. You can use you can specify the compressive strength using the standards, or you can manually define them. And the same for the reinforcement of the slab. You can define which grade of the rebars you're using for the slab. For the hybrid factor, which is I just mentioned, RH, when you check the box for the hybrid factor, then the icon is activated and you can define the materials for the top and bottom flanges and the web of the steel independently. So let's say you have a 36 on the top and bottom, and then you have on the flange another, or on the web you have another material. You can tell the program which material it is, and then the program determines the hybrid factor from there based on those materials that you define. Then we have something called the rating group setting. The bridge rating group allows the user to apply condition factors per different groups at the INN checked position, such as Here the selected groups are targeted for the design of the rating factors. For structural groups composed of SRC material properties are shown in the list after performing the analysis. Here you can also define different values of the condition factor. You can apply it to different structural groups of elements, and then the program will then consider the condition factor internally, and it's gonna multiply it by the nominal flexural strength and resistance, the shear, and the nominal fatigue resistance for the load factor. The condition factor can be inputted in accordance with the article 68423 of the manual of the bridge evaluation, and you can check the position I, N, or J, and if you select those group for the design. This is basically assigning a different group condition factor as per group. You know, if certain part of the bridge has a condition factor different than other part, you can group those sections or parts and assign the condition factors for each one of them. Then we have the here's the dialog box for the group setting, and here you can tell the program each one of the groups. The groups are defined under the group tab in the workstream. I'm gonna show you later when we see the model. But then here is where you can tell the program what the condition factor for each one of them is. Then we have the rating case. Here this is probably one of the important uses of the program. Here you can define each one of the load cases or rating cases that you want to perform. You have the service limit state, the strength limit state, and the fatigue limit state here. For the fatigue limit state calculation, only the live load can be selected. In this case, if you have the limit state, the service limit state, you can define what the load cases and the factors for each one of the load cases are there. You can use manually define them, or the program can take them automatically, and you can assign the factors out of the live load combinations, whether you can define them manually or you can do automatically using the live load for rating. The maximum and minimum load factors of each load type can be manually modified, as I mentioned, as per the manual of bridge load evaluation. And here you can tell the program whether you are performing a service limit state, a strength limit state. You have an option here for defining the load combination. In the case that you have an adjacent vehicle that you want to evaluate, you can also define the adjacent vehicle or primary vehicle. You can tell the program whether it is a legal permit load or design live load type of rating. Then you describe it and give it a name, and then you can just add it. We have an option for defining the position of rating output. In this dialog box, we have the option of tell the program what where the location of the output that we want to assign. That location of output is basically where the program is gonna generate an Excel sheet for the load rating, and you can tell the program what the position of that output is. You can select groups in the filter for the load rating table results on the Excel sheet, or you can select all of them in order to find the most critical elements of the composite sections. You can also select a group to limit the target elements to find out what the most critical elements are. When you apply this function, the elements to be printed in the output are defined and saved. So this is basically used to generate an Excel sheet. So You can tell the program whether you want to use it for the entire bridge to generate that Excel sheet, or you can do partial or portions of the bridge. For this steel composite, you can also define the longitudinal reinforcement. As we mentioned earlier, you have the option of defining the plans. I mean, in the load rating, you have to define the information based on the plans of the bridge. So in this case, you can also consider the reinforcement to perform the load rating. In a steel composite section, which is this case, you can define the arrangement of the rebar on the concrete deck, and you can use the program to define or to apply it in each one of the sections where there is a positive or negative flexure of the slab. Here's the dialog box. This function is called section manager, and here is where you define the longitudinal rebar, the size of the rebar, the spacings, and so on. We're gonna take a look when we start using the program. Then we have something called composite section transfer stiffener. When the transfer stiffeners are installed, the existence and spacing between the stiffeners determine whether the web is stiffened or not under the strength limit state. So you can define, for example, in this case, the flat stiffener, and you can give it the pitch and also the size of it. Whether you're using 1 or 2, you can also define that. And here is the diagram of how the program calculates these stiffeners. You have the T, which is basically the thickness of it, and then you have the height and the base and the materials, the Fy for each one of them. Then you, in the transfer stiffener, you have the stiffener type. You can also define 1 or 2. You can choose whether you're using 1 of 2 or 2. The 2 stiffener option is available for the I box top sections, and the pitch refers to the spacing basically. So at the strength limit state, this can be used to distinguish between the stiffener on stiffened web, or calculate the shear strength of the web in this case. So these are the different parameters that you can use in the program to define the bridge load rating. So now we're gonna see the application of the bridge load rating using the program. So let me just go into Midas Civil and show you how you can perform this type of design. So for those of you who are not familiarized with Midas Civil, this is the graphical user interface for it. Here we have the review menu, which is very similar to the menu that you used in AutoCAD or Microsoft Office, in which you have the different types of tabs that define the different type of functions that each one of the tabs have, or the program has. For example, you have the properties. Here you can define the material properties, the section properties, the load tab where you can define the loading conditions in the bridge or the structure that you are analyzing. Then you have the different types of analysis, the design functions in the program, and then the ratings, which is the ones that we're gonna use today. We also have something called the tree menu. In this case, you have all the properties that are defined in the model listed in this tree menu. We have groups that we will then use in the bridge to define the condition factors, but if you want to define a group, you can select it here and just assign it into a particular element or a group of elements. You have the tables in which all the properties are also listed in a table format, and then you have something called tags pane, in which you can load the program can tell you the different steps to perform a specific analysis. We have generated one for the load rating, and we're gonna also have it available for the users, so that they can simply just follow the steps listed in order to perform the load rating analysis. Then we have the message window. This is how the program communicates with us and gives us the information regarding the performance of the analysis and so on. And then we have the units here. Let me just first analyze this bridge. Let's just perform the analysis while we check the properties that have been assigned to it. So in this case, as I mentioned, we have the SRC property assigned to the steel composite. Here you can define the material for the steel and also the material for the concrete. You can also use this function to define the sections. We have positive moment section and negative moment sections. Here later we're gonna define the reinforcement for each section. And then we have the different types of analysis. In this case, we have a traffic lane, and we have defined the HL93. The HL93 is under our database. We have different databases from different states. We are implementing the loads from the different states in the US, and also we have the HL93 in our database loaded. In the case that the vehicle that you're using or a permit vehicle that you're using is not defined here, we have the option of defining the vehicles manually. There's a function in the program that is add user defined vehicle, and here you can define the permit truck. This is used. You can define the axles of the vehicle and the loads for each one of them. So just in case you have to perform the permit load rating, you have the options in the program. So let's start with the definition of the rating parameters. So we're going to the ratings tab. Today we're just gonna focus on that portion of the program. If you want to check different videos of how to generate this type of model or design these type of sections, we have an entire database on our website that you can use. You can simply access our North America website, which is northamerica.midasyuser.com, and you can use the reviewing courses option and select the type of what you're interested in, and then the program is gonna give you all the information that we have available for this type of bridges or any type of bridge available. Also here you can see the information of the upcoming courses as well. Alright. So let's first define the rating design code that we're gonna use. In this case we have dash.rfr in the program. Then we are going to define the rating parameters. As I mentioned before, here you can define a system factor, and you can tell the program which limit states you want to use for the definition of this particular rating. If you just want to use the fatigue, you can uncheck the other limit states, and then the program is gonna use the fatigue only for that particular load rating. You can define here the different factors for the resistance, shear, flexure, axial, compression, yielding fracture. Here are all the parameters. You can update them by the code using this function, or you can manually define them as you wish. Service limit state, auto calculated or user input, and the fatigue limit state as well. After that, we have the rating group setting. Here in this case, I showed you earlier that I had the SRC group. Here is the group for, let me just activate it to show you. Here is the group for all my girders. So I have assigned the girders into that particular group, and that's why I have used the SRC group for this rating setting. Here I can apply a condition factor. In this case, I only use the IN as a check position because the IN is going to be the JN of the following element. So I'm just going to use this check position. Then we have the option of defining the rating material. In the rating material, as I mentioned earlier, you can define the material for the steel rebar. Here you can tell the program what the material is, and you can also tell the program what the hybrid factor is. Here you can define the hybrid factor, top flange, bottom flange. As I mentioned, you have the option of defining manually the material, and you can define the concrete material for the slab and also the reinforcement for the slab. Here is already defined. Then we have the option of defining the rating case. In this case, you have the option of defining, for example, what the loading is gonna be for service limit state. So let's do a static load combination for the service limit state. Here you can define the minimum and maximum factors for each one of the dead loads. Also a temperature gradient. In the case that you have a temperature load, you can assign it here. In the case that you have some type of user defined, you can also give the program the user defined loading. You can select it from the drop down menu. You can remove any one of them. You can assign any of them. You also have an option for defining the live load factors. In this case, we have the service limit state, so all of them are 1. But let's say you have the strength limit state. Here we have the primary vehicle factors defined differently. You have here the load cases, but let's just go back to the one for the service limit state. Here we have the moving load. The moving load primary vehicle, as I showed you earlier, is the HL93. So that is the one that we're gonna use. And in this case, we're gonna use the design life load. Load rating. You give it a name and a description. In the case, let me just say service. In the case that you have it available, and then you can simply close it. If you want to define another type of rating, let's do a strength limit state, and let me just define the strength limit state. Use the combinations for the strength limit states. Here we have both of them. Let me just close it here, and then from there let's do the definition of the reinforcement for this particular section. So in this case, this reinforcement is assigned, but let's say you want to assign another type of reinforcement. So let me just remove this one so we can reassign it. Here is the section without any reinforcement. So let's just select the same rebar data for the INJN. We're gonna assign the same rebar information for each one of the sites. So let's say in this case let's define the coordinates based on the centroid. For the IN, we can define it depending on the sections that you have. You can define an arch, polyline, point, circle, a line. In this case, we have a line. We're gonna assign a line of rebars, and then here we're gonna assign the height and with the Y reference, which is gonna start at 3 inches, and the top reference is gonna start 4.37 inches from the top of the section. We're gonna assign 19 rebars, spaced 16 inches with a diameter of number 8 in the part 2, which is this is gonna basically do that. You have another method of inputting the rebar, which is this one, in which you can manually tell a program where the exact location just by selecting the rebar layer in this case, and that will be it. We're just gonna have this line of rebars here. We apply it and then we close it. If you want to go back to check the reinforcement, you can go back to the reinforcement just to make sure that it is there. Perfect. And then you can close it right here. Then we have the option of the transfer stiffener. You can tell the program also what the transfer stiffeners are in the case that you have one. So in the case that you have, you can, as I mentioned, apply the flat or T stiffener, and you can tell the program whether you're using one or two, and the pitch and the size of it as well. Then we have the option of defining the brace length here. As I mentioned earlier, the program can take that brace length from the bridge span information, so it's good. We had the fatigue parameters as well. Let me just, for the fatigue parameters, what I'm gonna do is I'm gonna select the SRC group, and I'm gonna assign the fatigue information. So we're using category C 1080 TSL, and we have 1 cycle. We apply it, and then that's how we assign the fatigue parameters. After that, we have the curve bridge information. So for the curve bridge, we assign the radius, in this case for this bridge, and let's just select the elements. Perfect. So after that, if you have any overhanging loads for the deck, you can tell the program what those loads are. But in this case, we have the loads applied in the model, so it should be fine. You can also run the diagnostic test result, and you can input the displacement and the dynamic factor if you want, and then the position for output. Let's just select, in this case I'm just gonna select one of the members for the output positions. Let's see, let's just select all of them just to have the most critical section. After that, we can check the parameters for each one of them, such as the fatigue parameters that have been assigned under the rating design tables, curve bridge information, diagnostic test information, and those properties can be also modified using these tables. So keep that in mind just in case that you need to change something in the model. You can also do the diagnostic or check the diagnostic and the position rating for output, as you can see here. And then after that, what we're gonna do is we're gonna just perform the design. In this case, let me just select for the output, let me just select the first 10 elements. So I selected 1 to 10, which is these elements right here for the output. Let me just perform the analysis or the rating design, and the program here is carrying the rating information. So going into the application of the bridge load rating in the program. The program Midas Civil calculates the rating factor at the I and J nodes of elements for the rating cases according to the ASHTOL-RFR standards, and it finds the minimum rating factor. Rating load carrying capacity needs to be done at 3 different levels. the design load rating, legal load rating, and permit load rating. And then basically the rating factor is calculated where it calculates whether it's safe to carry the primary vehicle. If the rating factor is higher than 1, it is okay to carry that vehicle. This is how the program calculates the rating factor. It is based on the um, capacity of the bridge in the strength limit state, service limit state. Also, depends on the different types of loads applied, and also is basically the rating factor is based on different types of the different loads applied, as well as the load factor for the structural component, the wearing surface, the permanent loads, the evaluation of the live loads, the condition factor, the system factors. It's basically a bunch of factors together with the capacity of the bridge. Capacity over demand, and then you get the rating factor. That's in summary how the program or how the rating factor is calculated. Let's go over the rating factor in the program. So let's take a look at the different results. In order to obtain the results, you can jump into the rating design results table, and you can see the service limit state summary. In this case, for the service load rating that we defined, here's a summary of it: short term, long term, stresses with its own allowable stress, as well as you can see the strength limit state summary for the strength load rating case that we defined. And here the program is giving you the information that the rating does not comply with the standards. So here you can tell whether or not the rating, in this case the strength, is not sufficient. Let's say the flexure. Let's just check the I node for the strength limit state. So everything is okay. You have the rating factors. As you see, most of them are, or all of them are, above 1, except for this one. Well, you gotta check that one as well as this one. But then most of them are more than 1, 2, 20, 18. So this bridge is pretty good. And then the ones that are not under that are not more than 1, the program will show you in red, so that you can just go back and take a look at them. Let's check the shear strength. Same for the shear. We can obtain the rating factor for the shear and check the ones that are not compliant with the code standards. You can also do a sorting, so you can sort as per the rating factor, so that you can see first the rating factors with the ones that are comply or not with the code, and then you can see from the lowest rating factor to the highest one, and that way you can, with that sorting, you will know exactly which part are close to the limit, which elements are below the limit, and then from there you can decide what to do with the bridge. We also have the steel stress rating factor, and you can do the same thing for the rating. You can do the sorting and see what the rating factor, let me just move the rating factor up, and you can sort it as per the rating factor, so that way the program can show you, starting from 1 in this case. All of them are okay, but just in case there was not one. Okay, then you will tell from here. Let's check the fatigue as well. But in this case, I didn't create a fatigue rating case. If you want to, you can define it here, and then you can generate it in the program. We also have an option in the program, which is the Excel report that you can generate, and you can create a new file or insert an existing file. You can save it as, and you can tell the program where the location is. I regenerated the Excel sheet right here, and you have an Excel sheet generated from those 10 elements that I created on the list. Remember, I selected them earlier. You can generate the rating factors for each one of them. You can also generate the shear rating factor for each one of them, the stress rating factor, and the fatigue, in the case you define a fatigue rating factor. You can also select or generate a summary for the load generated. And here, as you see, these are the load factors that were applied to the load cases. This is something that the program automatically generates, and this is something that, those factors, you have to eventually present them, so you might as well just do them here. And the program gives you the separate information for each one of the elements that you selected. So from there you can select the most critical one and generate a report like this one with the equations and the checks used for the standard ASHTO. You also have an option of defining the rating result diagram. So let's say for the flexure, for positive flexure, you can generate an Excel or a diagram. Let's check for a negative as well. You can tell the program to generate a diagram for you. Let's see the shear. You can see the shear factors generated for each one of them, and whether or not in the legend they are above 0 or not, or negative, as you can see here. So for the bridge load rating, we have different functions in the program that you can use. For the equations used in this calculation, we have the user design guide for the Midas Civil, ASHTO, LRFD, and LRFR available for you guys. We also have the model that we use for this particular presentation available for you guys. So here in this design guide, you can see all the equations that are used and all the considerations that are used in the program to perform the load rating for pre-stressed concrete and for steel bridges. And it is available for all of our users, and then there you can check the ASHTO clauses, the equations used, the consideration, what the program, each parameter, the definition of each one of the parameters that the program used to perform the rating. You can also find them there. This will be it for today. Thank you all for listening and for your participation. If you have any questions, you can submit it to our global technical support platform, which is globalsupport.midasuser.com. From there, we can answer all your questions if you have any. Thanks again for your participation, and we'll see you next time with the bridge rehabilitation session. Thank you very much.